So, yes, from India, thank you for coming. So, yeah, Japan. あ、ひかりさん。この間はどうも。
あり
So,
がとうござ
いやいや、
います。
ありがとうございます。Good to see you. So, Ito さん from Japan, nice, very nice. Oh, Philly, how great. Yes, nice. Nice to see you. Yes, nice to see you. Good, good, good. All right. Thank you for coming. Okay, so all right, thank you for waiting. Let's begin. So before we move into today's session, just a few words. So first of all, thank you so much for being here. I'm really happy we can spend this time together. So, and to our speakers, thank you for being here and sharing your time and experience with us. We have great today. So with different background and perspectives. So I'm really looking forward to each session. So, even one small idea can make a difference. I hope today gives you something meaningful, maybe inspiration, so curiosity or new connection. So, and please feel free to join the conversation. Say hello, share your thoughts or drop your things in the chat, please. So let's keep this space warm and open. So just quick introduction. So I started this community to connect the people, not only through AWS, but beyond that. So now I co-organizer this community with Yuki. Thank you, Yuki Streaming. So for support and growth this space with me. And if you'd like to get involved, feel free to reach out anytime. We'd love to connect with you. So, now let me introduce today's speakers. We have wonderful speakers, four speakers. So joining us today, Bila Soyapam, so Jambi, Harpreet, and Paulo. Nice to see you. So, and Harpreet is joining us for the second time. Thank you. So we are very happy to have you back. Welcome again. Thank you. So they are joining from different countries in the time zone, which really shows how global this community is. So we'll follow the order on the slide, and but it many chance uh, slightly, so depending on the situations. So each session will be about 15 or 20 minutes. So after each session, I'll share a short comment or question, and we'll love to hear from you as well. Please free to use chat anytime. So before sorry. So next, so we continue. So just a quick note. So you can join this Meetup Zoom or YouTube or whichever you prefer. So feel free to share your thoughts on X using hashtag AWS Global Community or in the Zoom chat anytime. And you are welcome to speak anytime or expect during the presentations. And most importantly, please be respectful and kind. Let's keep this space safe and welcoming for everyone. So next slide. So how many of you and joining for the first time today? And if you've been here before, welcome back. So I always share this because it's important to us. So this is a place where people from all over the world can come together, learn, and grow. So it's not about right or wrong answers. So what matters is what you notice, what you feel, and the connections you make. So AWS is our starting point, but the real goal is people. So we also welcome first-time speakers. This is a safe and friendly place to share. Hi, Jambi.
Hello.
Hello, good to see you. Thank you. So, we also have a Discord community. Feel free to join and continue the conversations anytime, even after the meetup. So, here's what's coming next. We host this meetup every month, and I totally hope to see you again. And we are always looking for speakers for upcoming sessions. This is a very open and welcoming space. You don't need to be an expert at all. So if you have an idea, an experience, or even a small story, that's more than enough. So this is a place where everyone can share and where every voice matters. So if you've ever thought maybe I could try speaking someday, this could be your moment. Please feel free to reach out to me anytime. I've would love to hear from you. So just to say to again, if you're interested, please feel free to send me message anytime. I'd really love to hear from you. We host, sorry. So we host this meetup the end of every month. So I hope this won't be just one-time connection. Please scan the QR code to stay connected and check out our upcoming events. And I truly hope to see you again next month, maybe not just as a participant, but as someone who share as well. So let's keep this going together. Yeah, so let's keep building this community together. And now it's time to begin our first session. So please join me in welcoming our first speaker, Bill Soy Upon. Already? Hi.
Yeah, hi, Hiromi. Yeah,
Hi.
thanks,
Thank
thanks
you.
for having me and giving the opportunity. Yeah, it's really
Yeah,
nice to connect with
yeah,
you
you
after a
too.
long time. Yeah,
Yeah, great, great, great to see you. So already,
yeah, yes, yes. We can proceed.
okay, I'm stopped right.
Okay, let me share my screen.
Yeah,
I hope my screen is visible. Is it? Oh, I think
yeah,
yes.
different browser.
Yeah, I hope my screen is visible now. Okay, can I proceed?
So, can you change the slide mode?
Sorry, I didn't get that. Okay, we share it out.
Okay.
Is it my screen is visible now?
Yes. Oh.
Is
Yes,
it visible?
yes,
Okay.
yes.
Okay. Thanks for that.
Can you change the slideshow mode?
Okay. Is it fine?
Yes, perfect.
Yeah, okay. Okay, great. Okay. Yeah, hi everyone. So okay, today we are going to discuss about how we can build our own custom LLMs, custom LLM platform using Amazon AKS. That will be our base infrastructure. We have to use, we are going to use Trainium and Inferencia. These are the AI accelerator, okay, AI accelerator chips that being developed by using Amazon. So using these tools, using these technologies and AI chips, we are going to discuss about how we can build our own LLM platform that we are going to discuss. So before starting that, let me introduce myself. I'm Veera. So currently working as a senior software engineer in Tech System India. So today I have a 6+ years of experience. So my core expertise in full stack development and cloud infrastructure. So that is where I'm having the experience. Yeah. So let's proceed. Check the agenda. So first we are going to discuss about what are the challenges we are facing when we are building, when we have the existing, for example, we are in market, there are already some of the LLM service providers also there, okay, which is like a OpenAI, and then Gemini. These are the LLM service providers already exist. So what are the problems we will face it, and then why we want to build our custom LLMs, and then cost wise, what are the things we will get the benefit. So that is the things we are going to first check, and then next we will check the architecture level. What are the components exist? So basic, the main components are EKS, just like a Kubernetes cluster, and Trainium is the chip specifically for training the LLM model, and Inferencia, that is for inferencing our that is the another AI chip specifically made for inferencing our LLM model after training is done. So using these main components, how we can build our entire total platform, and then in scale wise, how the Trainium chips really helping us. So it's providing distributed training and data strategies and Trainium optimization and inferencing side as well, how Inferencia, the two, how it really help us to reduce the latency and model serving. Okay, so finally we have a demo session as well, and later we will have the Q&A session. So if you have any questions, feel free to discuss it in the at the end of the session. So this is the agenda. So okay, so let's talk about the challenges. So there are three concerns. We can consider three like a parameters metrics, we can say. So first one, cost. So when we are using any existing third party LLM providers, cost wise we don't have any other control, we don't have any control of how much the subscription they are asking. Okay, so cost wise we don't have any control. So sometimes if you are using for our organization, if you are using some other third party LLM service provider, if you are using 1 million tokens uh, per month, that is very minimal. More than 1 million token we have to be used. So if your organization is very enterprise scale, so sometimes we will get the bill around like uh, like a 60K dollars. I'm just assuming that if when we are calculating it for a yearly wise, definitely it goes around 720K. It's a K dollars we will get at the end of the year. So cost wise is very huge. And then the set their based on their own business model, they can set that. So we don't have any cost wise control. And second one, and then the second point is, second parameter is control. Like for example, they can set their own rate limiting, they can set that. So per minute, per day, this much of request only we can ask to the LLM platform. So that kind of rate limiting and control also they can they have it. And then sometimes some of the LLM models over the night they can deprecate it. Okay, so that control wise also we don't have any like a privilege. And then third one is compliance. So some of us already like having we are working in health sector or fintech or a government projects also we will have to work. So in that case, it will not be allowed to send our project data to some other third parties. So that is not good. So compliance is also we don't have any control. Okay, so these are the major three challenges, three concerns: cost, control, and compliance. So let's check the cost wise. When we check the any LLM platform, the cost wise, for example, initially you are giving 1 million requests per day and 5 million requests per day. And cost wise, you won't see much difference, but suddenly it will go at exponential way. Okay, if you are giving 10 million requests, that will be the inflection point, and custom platform will be viable. Like we don't have any other control. Suddenly, the cost wise, we will get more bills. We will get that. So this is the major concern. So when we are using some other third party platforms. Okay, so architecture wise, okay, so before going into the exact architecture for this LLM platform, already AWS is providing various services like SageMaker and then Bedrock and Q Business and Q Developer. Already they are providing it. How this Trainium and Inferentia is different, like differ from existing services. Okay, so yeah, under the infrastructure layer, so we can see Amazon SageMaker. So that will help us to manage our like that is a managed infrastructure. On the top of it, we can define our the nodes, what nodes we want to deploy our model, that everything, the infrastructure nodes, we can define that. And then this Trainia and Inferentia, this is comes under the chip category. Okay, so like in computation category, we can say that. So these are the two chips, AI chips, AWS side they are developed. So which is really helped us to improve the training performance and inferencing performance. And then the bedrock that plays on the top of it, the infrastructure layer. And then there is a service, Amazon Q, and then Amazon Q developers also. So this is the generative AI stack from the AWS side they are providing it. Okay, so other than what are the chips, AI, like chips wise, AWS they are providing it for they are already they have a AWS Nitro system. Okay, AWS Graviton. And along with they have a AWS Inferencia and Trainium. That is what we are going to look into it. Specifically that made for machine learning optimizations. Okay. So the purpose, so this is the they are calling us a purpose built accelerator specifically for generative AI. So initially, Inferencia version 1 is also that. Now they are released Inferencia 2, okay, which is providing high performance, low cost inference, which is providing very low latency performance. We can get it. And Trainium chips also, it's that which is providing cost effective and high performance training. We can do it. Okay. So let's check. Okay, so now let's talk about what is Neuron SDK. Okay, so Neuron SDK, it will act as a adapter. So when we see at the bottom, we can see AWS Trainium and Inferencia. These are the chips. Okay, this is different layer in the infrastructure. Chips are different layer, and then your application cloud services are actually playing in different layer. So Neuron SDK, it will act as a adapter between our chip layer and our application layer and the cloud services layer. Okay, so using this Neuron SDK, we can integrate our Trainium chips and inferences to various services we can integrate. So we can use AWS parallel clusters and SageMaker also we can use it, and AWS Batch, AWS ECS, EKS, and various existing services also we can use it. On the top of the cloud service provider, we can deploy our other third-party applications after also we can deploy. So that is the purpose of using Neuron SDK in this generative platform, LLM platform actually. Okay, so now let's check the overall the LLM platform. What are the flow? What are the components it has? Okay, so initially the model experimentation. So model we will collect the first we will prepare the data set. Okay, and then we will create our model. We will develop that, and then we will train it. and then we will experiment the metrics and everything. Okay, so and then we will fine tune that. Once the model is ready, we will store the model into the container registry, like any model registry, we will store it. Okay, then finally we will serve the model in the uh, as a REST API or like a API service, so other clients they can access our model. So that is the flow. So this like architecture, it will give what are the components, what are the tools it exist. So for model experimentation, we can use Jupyter Hub. Okay, and model training and fine tuning we can use in that phase. The model will be trained and then evaluated and validated. So here we can use Kubeflow. So Kubeflow mainly uh, it's a kind of Kubernetes operator specifically for managing your model training and fine tuning. That entire flow you can configure it in the Kubeflow. Okay, and Ray also we can use it. That is distributed model training tool that we can use it. And then once the model is trained and fine tuned, that we can store it into the container registry that we can use easier, like a repository we can use that. And then the model registry, that also we can, that will help us to store our versioning and experimentation details. Everything it will help us to store. And then for model serving we can use like a case race and VLLM. These are the model inference engines available that we can use it. Okay, so on the below we can see the generative infrastructure. We can see S3 bucket that will help us to store model files. Okay, and okay, generally S3 we can use it for archive. Okay, so FSX, like the EFX, the file storage, we can use it for a model file store. So that once the training data is done, once training process is done, then we can store the uh, file store data, everything into the file store. Then we can set the mount point. So we can set the mount point to other inferencing server also we can set. So in upcoming slides, I will clearly explain that how we are going to EFS for our storing the models, and how we can serve, how we can mount, and how we can set the model point to the other services. Let's check that. And then there is a AWS Neuron Trainium and inference chips also there, and SageMaker also is there. Okay, this is the overall the component and the flow of LLM ops, the platform. Okay, so now let's talk about training at scale. So when you are going to handle huge amount of data, you are going to handle it. So there is a problem. If you are using CPU, one GPU, if you are using that, definitely some of the model doesn't fit, and cost wise also it will be very very heavy. Okay, the model training is also it will take more time. Okay, if you are simply using one GPU. Okay, so it takes 4 hours to train, and then it will take more time to train, and then generally we can consider for model training it will take 4 months. Okay, and then the cost wise also it will be very very huge. So if you are using trainium cluster, how it will work internally, it will execute the process parallel. Okay, simultaneously it will execute the process. Okay, so multiple chips actually working together, everything it will be managed under the hood. Like we don't want to do it anything under the chips layer. Trainium chips specifically made for executing the parallel tasks. Okay, so and then the cost wise also it will be 70% cheaper, and then training day is also very very less. Okay, within a 2 weeks, whatever we are trying take the times take to train for 4 months, we can easily reduce within the 2 weeks. Okay, so that is the difference between when we are using GPU and then training clusters. Okay, so, okay, how internally it works? So it actually split the model access 4 chips instead of one. So it will split the model and work together, and everything it will be executed in the parallel, and then it will be very very fast. Okay, so that is the major benefits of using Trainium. How is internally work. So, and next, check the inference side. So once model is trained, so we have to serve the model to the public. So then only we have to check our model with the real-time data. Okay. So the inference side as well, we have to provide high computation system. So then only we can get the low latency response we can get. So for the model serving is also, if you are using GPUs, so sometimes we can get, we will feel very slow time. We can feel that cost wise also it will be very, very expensive. So when we are in specifically inference of what it provides, specifically it made for low latency model serve. Okay, so we can expect the latency for the specific API call, it will take 100 to 200 milliseconds. Feels very instant. We can get the response. And cost wise also, it's 70% cheaper. So that is the difference when we are using. That is the difference between GPUs and inference tool, specifically for inferencing and models. Okay. So now let's talk about technical in depth. So what are the components it has, and how exactly it will look like. So this is the architecture diagram. So if you are deploying, if you want to build your own LLM platform in EKS cluster, okay. So let's talk about here we can see EKS cluster. Okay, there are three different namespace. You can see the three different nodes categories. You can see. So the first one, system node. So here it has by default three T3 node, which is like a normal like a compute type, like a normal node type. So okay, so whatever like non-LLM task, non machine learning task, if we have it, that everything we can use it in the normal EC2 instance. We can use that. Okay, so here I have a core DNS and then a LB controller. Okay, and then this neuron device plugin. Why we need this neuron device plugin is previously we discussed about neuron SDK. Okay, so that will act as a adapter between uh, our AI chips and the neuron trainium and inference chips, and then your cloud services layer. That it will act as a adapter. Same thing, Kubernetes also different environment. Okay, so your Kubernetes should know the specific node, the specific like like a EKS node. It should have it has the trainium nodes. It is the inference node. These are the neuron node. So your Kubernetes should know about it. So that's why we need neuron device plugin. We have to deploy this neuron device plugin as a daemon set. Okay. So whenever there is a new node is created, this neuron device plugin also it will be added. The service also will be added. And then when there is a job is when we are going to deploy any job, any service we are going to deploy it, first what it will do, it will check any neuron node is exist or not. If it exists, so it will deploy the specific LLM jobs to the specific neuron node. So that is the responsibility for neuron device plugin here. Okay, and then here we can see trainium nodes. So I'm using trainium 1 2x large, so which having two neuron core. So how we can calculate this like the resources, I will discuss it. We will discuss in the later if we have a time. So there is a separate section I have. So for example, if you going to create your own LLM platforms, how much resources you need, so like how much RAM you need, how much memory you need, which model we have to use it. So that everything I have a separate section. If time permits, we will discuss about later. Okay. So here I'm going to use a tiny LLM, okay, which is like a 1.1 billion token parameters having the LLM. So I'm actually downloading this LLM from like a Hugging Face. So you can use any open source LLM providers. You can use that. So first we are downloading it from Hugging Face, and then in our we are downloading into the Trainium nodes. We are actually training with our own custom data. We are training it under the Trainium nodes, and then once the training is done, next we are saving the model to like a EFS. Okay, so we are it's kind of shared file share. Okay, file share service. So once model is saved, and then the next inference node it will be triggered. It will start. It will take the latest model versions model. It will take the latest model, and then it will start the inference server. Inference server is nothing. It's like a fast API, Python API service. Okay. So here also we are using inference here 2x class. That's also having two neuron core. Okay. So and then on the top we have a application load balancer that will redirect all the API requested to the inference server. And then we have a CloudWatch that will help us to monitor the like the metrics and API calls and the logs, everything we can uh, capture it, we can monitor that. And then we can use S3 bucket. So that will help us to keep our model if we want to archive, if we want to store old models. So we can use the S3 to as a backup. Okay, so these are the architecture, these are the components we need if you want to build our own LLM platform. So let's talk about in code level. In code level, what are the changes we have to do? So I just want to know how many of you already having experience in Kubernetes. I hope some of them already having the experience in Kubernetes. Okay, okay, okay. Even if you don't have experience, no issue. I will try to explain this concept in very beginner friendly. Okay, so Kubernetes is a orchestrated service provider. So we can deploy our container application. We can deploy our Docker applications, containerized application in the Kubernetes. So it will help us to manage multiple containers, orchestrate and distribute your traffic. That it will help us to manage. So that is the purpose of using Kubernetes. So when we are in this code requesting for neuron devices in Kubernetes. So if you are writing your YAML script, so YAML script means YAML script you have to define your deployment configuration and service configuration that you have to configure it. So for your specific service, for example, I have a Python application. I want to deploy it into the Kubernetes. So I have to first create the deployment service. I have to create that. In that deployment configuration, I have to mention how many CPUs, how many memory it's needed for running this application. That I have to mention in my resources section. So, for example, in neuron devices, yeah, we have to mention aws.amazon.neuron, and then how many neuron nodes we need. Okay, so here I'm requesting for one Trainium and inference devices of neuron device I'm requesting to run this specific service. So then Kubernetes it will decide, okay, so this specific service it will be deployed into the neuron nodes. Okay, this is just Trainium or inference node. We have it will manage it. Okay, so this is how we have to define that. And next, okay, slide 7. Yeah. So next, once sometimes Kubernetes also it will make mistake. So if doesn't know which node is neuron node, sometimes which node is like a like a non-neuron node. Okay, so even we are having the neuron SDK plugins that will help us to send the details. But to Kubernetes, this is the neuron node, this is the non-neuron node. But sometimes we have to for a like a backup compatibility, we have to set node affinity. The time also we have to set that. We have to restrict it. So the specific node it will be only deployed into the neuron related, like LLM related tasks only we have to deploy. And then like some of the nodes it's having the normal nodes, normal EC2 types it has. So non LLM jobs we can deploy. Okay, so like here we are actually doing the taint and tolerance, like node affinity we are setting it. So it will make sure LLM jobs related, all the LLM jobs it will be deployed into the neuron nodes, and the non LLM jobs it will be deployed into the like a normal EKS node. Okay, so that affinity we are doing it here, that will help us to prevent the cost wise per hour 1.3 cents. It will help us to save it. Okay, and next, this is the basic code how the training is actually we have to do that. First we are actually downloading the LLM from Hugging Face. Once we download that, so we have to train the model with our, if we want to add our train the model with our custom data, how the code it will look like. So we have to use PyTorch plus the neuron SDK, we have to use that. And then we have to load the model, and then we have to use the optimizer. Okay, and then we have to run the training loop, like the training batch loops we have to run that. Okay, so this is the basic example code we can use it. Okay, so once this is the exact code it will look like. And next, okay, so once model is trained, we have to serve the model as a API service to public users. Okay, so I'm using fast APIs. Based on your requirement, you can use Django or any other API service. You can use it. So here, once the API is created, and then we are actually getting the model from the EFS or where we are storing it. So this is the reference code essentially. So and then we are actually providing the interface, the API interface. We are providing that in here. We are actually using serving, getting the request and sending the request to the LLM model. Okay, so finally it will return the response. So this is the like inference sample code. Okay, So now let's talk about cost wise how much we can optimize. So even the instance wise, is to instance wise in our EKS cluster, rather than using on demand instance for training jobs, if you are using spot instance, we can save almost 70% of the cost. We can save it. So because the training jobs, we are not going to run the training jobs for most of the times. Okay, so we only sometimes it will take to complete some of the jobs within less than 10 hours or 12 hours or 5 to 6 hours only it will take to train the model. Okay, so in that case, we can just use spot instance. Cost wise, we can save 78%, 70% we can save. So that is one of the optimization we can do it in the cost wise. Okay, so next, okay, so this is we already discussed the neuron device plugin, how it works. So we have to set it as a daemon set. Okay, so whenever there is a new node is created, it will be attached, and then it will send the details to the Kubernetes worker like a control plane. So it will make sure the specific node is neuron device or a non-neuron device. So it will make sure your application is it will be deployed into it will make sure non-LLM jobs it will be deployed. It won't be deployed into the neuron node. Okay, so that is the purpose of using neuron based plugin. And then okay, so demo side now. So here I already pre-recorded that the demo. Why I pre-recorded that the entire setup it takes me almost 35 to 40 minutes. So in the entire setup, we will deploy, we will create the EKS clusters, we will add all our Trainium nodes, inference node, we will download the like tiny LLM model, and then we will train that, and then we will inference, we will start our inference server, and then finally it will provide the API URL, and then we will hit that API URL, and then we will ask some questions. Based on that knowledge, it will just return the response. So that everything already pre-recorded. Why I do that? The entire demo it took me almost 35 to 40 minutes. Okay, so let's check that. So here I used Terraform, so that will help us to implement the entire infrastructure, EKS and nodes and everything to help us to deploy. So it's actually deploying all the resources. Yeah. So here we can see the cluster name. So EKS neuron demo cluster. We are deploying all the training and inference, everything we are deploying it now. Okay, let me forward. Okay, so the finally we can see. Okay, so once the deployment is done, then it will try to start the servers. Okay, so once that is training and inferencing everything is done, it will provide the API URL. It will provide that we can test it with our own questions we can ask. Okay, so here I'm just asking. Oh, okay, I just asking some of the basic question. What is AWS? So I will provide the demo, the repository code. I will provide to you. Okay. You can play with that. You can create your own training. You can create your own LLM platform. You can create it. At the end of the session, I will share the recording. Okay, so you can work with that actually. So I think that's it. So based on his knowledge, it will answer it. So yeah. So now let's proceed with resource calculation. I think still how long we have? I think still we have enough time. Right? Okay, so how we have to calculate the resources? Yeah. Okay. So for example, in memory calculation, how much memory, the RAM or the storage, how much we need for inference and train. Let's talk about inference. So based on the model for memory, we have to calculate parameters, how much the model parameters it has, and then each parameter how many bytes it takes, okay, and overhead with 1.2 we are just providing additional spaces for inferencing, okay. So for example, if Mistral, if let's take talk about Mistral 7 billion token, it is in having BF 160, so that is the persistent. So persistent means that's for specifically for how many bytes it takes specific for specific param, okay, for each param, okay. So BF16, it will take 2 bytes, okay. So for 7 billion tokens, and then if it takes 2 bytes, we are actually additionally providing some extra spaces. So and then now we are just multiplying with 1 by 2, and then it takes 16.8 GB we have to allocate for inferencing for Mistral 7 billion. So okay, so that is the memory we have to allocate that. And for training as well, um, the same, the parameters multiply with the bytes per param, and multiply with 4. Why 4? We have providing additional spaces for model and gradients and optimizers. So these are the additional resources. Also, it will be downloaded. Okay, so that's the reason we have to multiply with the 4, and then for example, if you're same for calculating for 7 billion tokens, Mistral NBF 116, so we have to it will take almost 56 GB it will take that, okay. So that is the memory calculation equation generally. And then for a Persian impact on memory. So what is a Persian is? So there are various levels of Persian for each model it has. So if the model having floating point 32, and then like a BF16, and then INT integer 8. So based on this Persian, we can say the model is providing high accuracy result. It will provide that. Okay, so it takes, if for example, if FP32, it will take 4 bytes for each params. Okay, so generally for 7 billion model, it needs 28 GB, and then for 30 billion token model, it will needs 52 GB, and 70 billion model, it needs 280 GB. Okay, so that is the resources we have to allocate based on the Persian for a specific model. Okay, so and then instance selection. So now I have the model, I calculated my resource, and then how many neuron nodes I have to provide that to train that model, and then run the model. Okay. For example, if the model size is 1 billion token to 3 billion token, if the memory we have to provide 8 to 12 GB, and then the instant choice we have to provide inferencia. This is for inferencia. Okay. So inferencing server. So inferencia X large, it will provide the 2 neuron core. It will provide that. And if the no like a model size is 7 billion token, then memory we need almost 14 to 20 GB. And then we have to provide 2 neuron core. We have to provide, if the model having 7 billion token, we have to provide 24 neuron core. We have to provide that. Okay. So now let's talk about cost comparison for 1 million inference. So if we take that the scenario, so for example, if you are using any third-party service provider like OpenAPI, GPT, so for 1K inference tokens, it will cost around 60 GB. Sorry, $60. And then in the bottom, we can say if you are using for inferencing, if we have built our own platform with the EKS and inference, yeah, spot instance, if we do that, the cost wise, we can see the huge difference. It will only take 0.70 cents only, it will take that. So if you are using OpenAI for 1K reference, it will take $60. If you build our own platform, it will take only 0.70 cents only. That is a huge cost cut, we can say, okay, for inferencing. And then training wise, for example, if you are using SageMaker GPU model, if you are using it, and then for 10 hours training, it will take almost $327. It will take almost. If we build our own infrastructure with like EKS and Trainium Spot instance, if we use it, it will take $4 only. We can see 70% of the cost wise it will be reduced. Okay, that is the cost wise difference we can see. So the key takeaway is, so cost wise we can reduce 50%, we can reduce it, and inferencing side wise also we can reduce that, and then latency wise we can get 100 milliseconds for 7 billion tokens also, because Inferencia 2 is specifically made for low latency and model 7. Okay, and then we can build the entire platform, everything in our control. So cost wise, control wise, and compliance wise, everything, all the problems it will be resolved. So everything in our control. Okay. So yeah, so this is the, you can take the screenshot or for this QR. So here I added the repo link, the demo I gave you, right? Like so the repo here. So you can clone that and then you can play with that. Okay. If you took the screenshot, then I can proceed to the next. Yeah, so if you have any questions, feel free to ask. I think that's it from my end. So if you have any questions, feel free to ask. Okay. Okay, so if you don't have any questions right now, maybe once you start using, check the like check the repo. If you having any doubts or any support you need, feel free to reach out me in the LinkedIn. This is my screen is still, yeah. This is my LinkedIn handle. So Veera26. So you can feel free to reach out. That's it from my end, guys. Thank you.
Thank you, Vila. Thank you. So I see there are some questions coming in the chat. It's Mich Michore. So good. Good evening, everybody. Any chance do you provide e-certifications? Oh, a bit of mute.
No.
Can you hear me?
Let me share the thing.
Yeah, there are one question for you.
Okay. Which one?
So, by any chance, do you provide e-certificates?
I think e-certificate for attending the session. I think that is what they asked.
Oh, thank you. Thank you. So, and once again, thank you for your great session. So I think AI technologies bring us a lot of value, but at the sometime cost optimization, it's becoming so more and more important. Yes. So in my company as well, this is something we are actively are working on, and we are building up knowledge together. So your tips on large scale training are very valuable. Thank you for such a great and insights sharing. Thank you so much. So again, does anyone else have any question or comments for him? Okay, nothing. Thank you. Thank you. So, all right, let's move on to our next speaker. So, Jambi, are you ready?
Yeah, just give me a second.
Okay. Okay.
Okay.
All
Am
right.
I wait? I'm facing some issues with my video. Okay. Now is it visible?
Great.
Done. Yeah. First of all, it's really great to see you in like in virtual face. But yeah,
Yeah, thank you so much. Do you have a slide?
yeah, I do. Let me
Okay.
just a second.
Nice.
Oh, wait. Hmm. There isn't. Hmm.
Mm-hmm.
Okay. I'm sharing my entire screen. Sure.
Oh, great.
Okay. Is this visible?
Oh, great. Yeah, nice. Very nice.
So, hello everyone again. Before we start, have you ever been in a situation where you're slightly out of the place, slightly unprepared, but for some reason people are looking like at you like you have the answer? And that moment, I'm sure a lot of you like me would be thinking, why me? But also slightly realizing, if not me, then who? And I found those moments very easy to dismiss. Like I'm sure a lot of people like me will tell ourselves like, I'll step up next time, I'll be more ready next time, I just need to know a lot more about this before I go in, right? But what if those moments are your moments? And that is today what I'll be talking about, leading before you feel ready, what the AWS community taught me about true leadership. But before moving forward, hi everyone again. I'm Janvi Bhagchandani, a cloud enthusiast at heart and an AWS community builder by a tag. Over my journey with AWS community, I've collected quite a few labels: instructor, community lead, organizer, speaker. Basically, enough tags to look like a full configured, resource in the console. But among all of it, what excites me the most is not the certifications or the service, it's the humanity changing side of technology. And the part where, systems just don't scale infrastructure, but they scale human capacity. So that's a little intro about me. And let's go straight into it. I want to start with something very, very simple. When I first got involved with Amazon community, AWS community in general, I had a very clear expectation. I thought I was only here to learn cloud, basically cloud services, do certifications, acquire those technical skills. And honestly, I did. I had so much fun. But somewhere along the lines, something very unexpected happened. I didn't just learn what to build, or I just didn't just learn what to learn about cloud in general. I started to learn how to show up for people and with people, and that changed a lot, like a lot more than I anticipated. And that's when I realized, that was the time where it actually clicked to me that leadership doesn't come from a title. Before this, I thought that I was a good leader. I thought I have been part of so many, my university cloud leads and everything. So I should know what a leadership should feel. But then it stuck to me when I was part of that AWS community as a cloud captain, as a community builder, that it shows up in moments. Small, slightly uncomfortable moments where, something needs to be handled or something, it ends up being you somehow. Not because you're the experienced one, but because you're the most confident. Or, it could also be because simply you're just there. And that's one of the things I noticed while being part of this such beautiful community was that I was often stepping into such situations that I didn't feel ready for. It could be, hosting sessions, managing events, taking decisions. And internally, there was always that thought that maybe, I should wait because I don't feel fully prepared. But, that's when I realized that psychologically something very interesting happens over here. Avoidance feels very safe at the moment, but it actually increases anxiety. And that's when I realized when I was just an AWS, enthusiast. And from that, I changed to becoming a cloud captain. Expectations from AWS had changed instantly. I was now responsible to take charge of events, organize without having that prior information or experience. And, I was a beginner myself too. But that spark, that action on one hand, even if it was imperfect action, reduced a lot of my anxiety. And I started seeing this pattern. The more I wanted to feel confident, the more uncertain I felt. And that moment acted, even if I acted it very imperfectly, I understood that clarity always followed. And over time, that happened that I stopped asking myself that, am I ready? And started asking this question, can I take responsibility for this? Because for me, confidence never came first. But it always followed with an exposure. And that's what I realized, when I first showed up as a cloud captain and I was hosting the session, or when I transitioned into an AWS community builder and I was part of the, such a wonderful volunteering team for AWS Community Ahmedabad, I always felt like I am not fully prepared. I don't know what ahead is in front of me. But even when in my unpreparedness, I went there and I just, directed what my heart desired, even if I made mistakes. The next time it created a lot more confidence in me to step up for the second, event in AWS community in general, or, be a much more confident about what I want for myself within this community. And that's when clarity hit me. Another shift happened, when I started explaining things to others. I thought I understood concepts really well, AWS concepts very well enough, until I had to explain it to somebody very simply. And that's when I realized the gap was very visible. Psychologically, there's an idea, let's just say. But if you're not fully able to understand or, something, we cannot externalize it until we put into words. And that what kept happening with me when I became the AWS captain first, or when I was started joining AWS community. I became a builder and I started joining AWS community. There was a shift in my mindset of services, like how the services should be explained and everything. But I kept feeling, and often, what happens is that we sometimes don't realize the people who are coming in that community, like me, who when I first started, I was someone who didn't know anything. So they are also the same, that they might not know anything and they might feel overwhelmed with so much information. So the main purpose behind everything is to make it so, so clinically, so, technically so sound and so non-judgmental when explaining it to them, that they feel, they feel like they can grow over here, learn and explore. Because thinking in your head is very forgiving. Explaining it to someone else is not actually. And through sessions, conversations, and even casual discussions, I realized clarity isn't built by consuming more information, actually. It is built by trying to make sense for it for someone else. And that's a very different kind of learning that I learned from this very vibrant AWS community. Another thing, which is my favorite learning. is that when you start working in the community, you always think that you'll be managing task. But then very quickly you realize that you are actually working with people around you. And people are unpredictable, for sure. They have different motivations, they have different energies, they have different ways of thinking. And that's when the truth hits in that people are not driven purely by logic, they are driven by how they feel. And this shift I noticed when I was a cloud captain and I had a cloud, team to follow up with. I understood every volunteer had a very different motivation or very different energy level coming in. They had a very different perspective of an event execution or what different perspective they want to bring in. So sometimes I realize the most effective way to be a good lead or to be a good teammate is to not do anything to solve the problem immediately, but is just to listen to them. Because, sometimes in this fast paced world, we forget that just being understood often matters more than being corrected. And that shift in my approach chose made things very different. It quickly became to let me fix this quickly to, let me understand what's happening over here. And that's when I realized that understanding team concerns before, assigning roles for any event. And that was one of the much bigger lesson that I learned while being a cloud captain, while I was the one reporting to the official AWS team about, cloud club team. And I had the wonderful heads and managers in there where they would explain this to me, like, maybe you're rushing and this is how you should approach. And that shift in clarity taught me a lot more about how much actually a true leader means. But there are also moments where things don't go as you planned. Events don't run perfectly. Sometimes anything can go wrong. Sometimes not always everything is going wrong for some reason. And in those moments, I realized something very subtle but very powerful, that emotions are contagious, especially from the person you're looking at for. If you panic, it spreads. If you stay composed, it also spreads. So, leadership in those moments wasn't about control, it was about regulation. Regulating your own response because your state becomes the environment for everyone else. And that's what I realized when I was being part of, AWS as a community builder, being part of AWS community days. You're handling out 800 peoples out there. I would also be, hosting at times. And there is another kind of pressure that you feel that, oh my God, if I even if I make a very subtle mistake and nobody has noticed, I might panic and they might recover. Even if they have not noticed, but because of me panicking, they'll notice that, yeah, she must have messed something up. So this is what I understood with being part as a community builder, that always regulate yourself. Another big key reason and key lesson that I've always learned is it is very something very simple but very often overlooked, and that is consistency. Not the big moments, not the one time efforts, but just showing up again and again. Even if the response is low, even if it feels like you're unnoticed, because psychologically trust isn't built with intensity, it is built with predictability. People trust what feels consistent. And over time I realized that leadership isn't about being very impressive or being over the top or something. It's about being reliable. They should feel that you will show up for them no matter what, that you will cheer up for them no matter what. And so when I look back, I realized that I didn't learn leadership in one moment. I learned leadership in many, small situations from AWS community in general. And that is like maybe saying yes before I felt ready, explaining things I thought I understood, listening instead of reacting, staying calm when things were uncertain, showing up when it didn't feel significant. And all of this happened almost very unintentionally. So maybe leadership isn't something you become in one day. Maybe it's something you practice in small ways, consistently. And maybe the question isn't, am I ready to lead? But rather, in this moment, how can I show up, a little better than before? And honestly, that's what I'm trying to do right now, too. And surprisingly, that's been very good enough for me to grow. So, I hope this little talk of me, of how AWS, has reflected and impacted me in such ways where I understood leadership, I understood volunteership, understood, responsibilities in such a valuable lesson and shell. And I hope this conveys to you, whoever is listening and is just wanting to take that one step in the community. I would really love to hear about your leadership experiences too. So here's my QR of my LinkedIn where you can, maybe type me a message. I love responding to you guys. Or if you guys want to have a chit chat or follow up with some of the slides that I mentioned, I'm up for that too. And that is it from my side.
Thank you. Thank you, Johnby. I'm
Thank you
really
for
happy that
having me.
you chose this meetup to share your today. Thank you so much. Yo,
Thank
so I and congratulations, Club Captain. Beginners joining us today. So I really appreciate you taking about community leadership. So I actually joining the AWS community leadership event in the Philippines last year. So
you.
yes, great memory.
Yeah.
Yes. So and it was such an amazing experience. A really, really great memory. Yes. So, all right. Does anyone have any question or comments or thoughts for her? Hi. Oh, nice. Really interesting. Great. All right. Okay, thank you. So, and once again, thank you so much. Thank you.
Thank you for
Yes,
having me.
thank
And you
you.
guys are so lovely people. Such a good energy coming up from you guys, even if I'm seeing it virtually. So I'm
Yeah,
really much more fortunate for that.
yeah, thank you. Let's keep catch.
Yep. Bye bye.
Okay, so all right, let's move on to our next speaker. So, Hari, are you ready?
Hi, Romy. Yep, I'm ready.
Hi. Okay. Oh,
Can you, Janvi, I think you need to stop sharing.
yeah. Okay, stop.
Can you see my screen?
Yes, great, perfect.
All right. Okay, so good morning, everyone. Good afternoon, good evening, wherever you are. Thank you for having me at AWS Global Community Gathering. I'm super excited to be here with all you today. My name is Harpreet Sidhu, and I'm an AWS community builder and AWS Road to Reinvent Hackathon champion. And today we are going to talk about something that I personally find very exciting in the serverless world, basically, and it's the AWS Lambda deliverable function. So AWS recently launched this in reInvent 2025, and this is a relatively very powerful tool, basically very powerful feature that you can use for implementing multiple workflows. Since it is still new feature and very important for us to understand what are the tricks and traps that you can basically take yourself into whenever you implement or use this feature in production based systems. And today I'm going to walk you through those traps and gotchas so that you don't fall in them in production. So without wasting any further time, let's get started. So let me start by quickly setting the stage. Who is this session for? So if you're a developer building with AWS Lambda function, even if you're building like basic things, this is for you. You don't need to have like knowledge of duration functions because we are going to start from basics. And by the end of this session, you will understand like what durable functions are, how they work under the hood. And most importantly, you will know 5 mistakes that could cause serious issues in production. I have personally experienced these issues with my workflows, and I spend like hours debugging those issues for my workloads. And the reason was like these gotchas and basics that I'm sharing today was not known to me that time. So before we go, let's talk about basics. So what are Lambda durable functions exactly? So let me explain this in very simple terms. Think about a normal Lambda function. It runs, it finishes, and then it forget everything because it's stateless, right? And this is really good for simple tasks and simple use cases. But what if you need to coordinate a multi-step workflow? What if like your step 2 depends on step 1 and one of your step is now taking like, for example, 10 minutes? With normal Lambda functions, what you would do, you would basically introduce step functions or you would build some state management using DynamoDB. But with durable functions, you can solve this. Basically, it's a single Lambda handler, and you can define that for long running workflows with multiple steps. It can pause, it can wait, it can resume, all within the same code. And AWS launched this feature as a part of their durable execution SDK. It is relatively new, but it is pretty handy for building complex serverless applications. Now, before we go and learn more about the gotchas and the traps, let me quickly go over 3 key concepts that you will need to know first. First one is steps. So these are the atomic units of work in your workflow. They are like idempotent and their results are persistent. Idempotent meaning like if you run them multiple times, the return value will not change. It will keep processing the same thing, but generating the same answer for you. Second is the child context. So you use this when you want to run things in parallel. You get like run in child context or parallel and map. And these are like helper operations for you to run in parallel. Third one is the durable execution SDK. And this is the SDK that you add to your Lambda to get all this functionality and helper methods within the Lambda context. So whenever you start coding in Lambda, you have to first include the SDK. Once you have the SDK, you will get these helper features or helper methods like step and map, parallel, and wait, and all these things. So important thing is you need to first have this SDK in your Lambda function. Now, the most important concept that we need to understand here is the checkpoint and the replay model. Now, let me walk you through it carefully because every single gotcha that we will discuss later comes from not understanding this model correctly. So when your durable handler runs, it executes every step one by one, basically. After each step completes, the result is basically saved as a checkpoint in some database, and AWS takes care of that. If Lambda function is interrupted, say it times out or there is some failure or some kind of uh, some problem in your code, so the framework will restart your handler from very beginning. And the key is it will not like re-execute all the steps which was already checkpointed. Instead, it replays them, which meaning that it skip the actual work, just load the results from the database. Okay, and this means your handler code will run from top again, and it will execute all the things within the step if you have any code inside it. And that's the thing that we need to talk about here. Like if you have any code within that step, those code you need to take care. And these are the traps where you can basically take yourself and introduce new bugs into your system, right? So this is the code actually looks like. You can see a sample workflow. And here I'm running step one, but I'm using the context and this step helper method and running my step one. And then if something happens, for example, in step two, and it fails or times out, then durable function will basically replay this step. Whatever is inside this will be skipped because we already have a checkpoint and save that information. So this fetch data information will be fetched from the saved checkpoint, and then it will come back to this step and try to execute it again. And this is how it basically works internally. Now, what are the real world use cases? So the classic example is the order processing, where you receive order, charge payment, and then reserve your inventory and send confirmation email, or probably update your analytics system. And these 5 steps basically, need to happen or need to run in sequence. And if Lambda times out, let's suppose in midway, you do not want to charge the customer twice, and durable functions handle this for you. Another example is the document processing pipeline, where you extract, run ML classification, store results, and then send notification. Or anything with the human in loop, where you pause execution and wait for human to approve something. And there are many other use cases, as you can see, with which you can implement using Lambda durable functions. The key insight is use durable function when your workload has multiple steps, when failure should be retried from the point of failure rather than from scratch, and when you want to avoid complex state management, like what we do with the, when we save in DynamoDB and all that. All right, so now we get to the important topic that everyone should know before using Lambda durable functions, the 5 gotchas. I want you to pay close attention here because these are not theoretical edge cases. These are the things that will cause real bugs in your production system. And if you're not careful, you probably will end up introducing them. And the tricky part is that these bugs often show you when you replay Lambda durable functions, which means that it's pretty hard to reproduce in your local testing environment. So listen carefully, look at the code examples, and think about how you can avoid these things in your code. The number one is non-deterministic code, and this is the biggest one. Let me explain you what exactly non-deterministic mean in this context. First, let's understand what is deterministic. It means given the same input, you always get the same output, right? For non-deterministic, you might get a different output even with the same input, because you are using something like math.random or date now or timestamp, something like that, right? So now look at this broken code here. What we are doing here is we are generating a random number, and then we are checking if the random number is greater than 0.5, then go to the path A. And if it is less than that, then go to path B. Now on the first execution, let's suppose if we are getting a value 0.7, so it will go into the path A. And if in the next time, for example, if Lambda interrupted and if it want to replay your code again, it might go into the path B. And that's what is non-deterministic is. So you should not be coding your or adding code which will produce different results whenever Lambda durable function is replaying your logic, because it will end up generating different results and you will end up having corrupt workflow. So now what should be the correct way to fix this problem? You need to move your non-deterministic call inside a step. So when a random number is generated inside the cxt.step, its results is basically stored in the check or the check in the database as a checkpoint. So on replay, the step is skipped and the original value is returned from the checkpoint. So any value for math random, which is like 0.72 for the first time, and this 0.72 will be saved, and on replays, your code will be deterministic and it will execute the same code again and again, and it's mainly like idempotent, right? Now this random thing, math.random and other things like date now, there are other things like timestamps and UUID, which you need to basically add in the context step so that those values are checkpointed and stored by the Lambda durable functions before you write anything in your code. So the important step is this basically is context dot step. Anything which is non-deterministic should be part of this step, and then it will be checkpointed. Number two is the side effects outside step. So remember like what I said earlier, like code outside steps run every single time, right? Whenever your handler replays, it execute that code every single time. So if you're calling an external API or probably writing to a database or generating an email outside the step, that action will happen again and again on every replay. Now look at this broken code here. We are calling send welcome email before and between steps. Now if Lambda replays 3 times before completing, the customer gets 3 emails, right, in this code, because we have this code which is outside the step, and this is not checkpointed by the Lambda durable function. So in case of failure, and when we are trying to, let's suppose, running this step, it will go here and it will see that, okay, this step is checkpointed. It will get the data from the database, but this code is not checkpointed. So it will try to generate this email again. So if it is trying 3 times, it will generate email 3 times for the customer. Now, what you would need to fix it, basically, you would need to save this inside the context step. Number 3 is mutating closure variables inside step. Now mutating means like changing. If you are changing a variable inside the step, you need to be careful here because if you are mutating that value and you're doing some other work and not returning the mutated value, the same value will not be returned back when the Lambda replays. So here in this code example, you can see like we are setting the counter to 0. Consider that we are running it for the first time. So for the first time, we will set the counter to 0. Lambda durable function will try to execute this for the first time. It will set the counter to 42, but the return value is some work. It's not exactly counter values 42. And then this do work or whatever return value will be checkpointed and saved in the database. Now, let's suppose something happens and this step fails. Lambda durable function will try to replay this whole thing again. Here it will set the counter to 0 because this code is outside the context step. So again, your counter is 0. This step is checkpointed, but the return value is do work. So we are not setting the counter to 42. And then we are going to this step with a counter value 0. So that can again cause problems in your workflow, and it will not run exactly same thing if you are mutating the variables inside the step. So what is the right solution for this? The right solution is whenever you want to mutate anything inside the step, always return that value. So here we are setting the counter and then we are returning the mutated value instead of some other value. Now, next time when it will run, this value 42 will be saved into the database, and this is what will be restored during the replays. So that's how basically, you need to think about whenever you are writing code, what can change when the Lambda replays. And based on that, you need to figure out whether you need to return a value of that variable, or whether you want checkpoint those things so that whenever replay happens, your code should be idempotent. Number four is a dynamic step name. So, this is again very important. If you are naming your step with a dynamic name, for example, here you can see in this code, I have a step where I'm naming it as process date now. Now, what will happen? It will, for the first time, the timestamp or the date could be date with the timestamp could be something. Uh, for example, let's suppose it's 123. But next time when it will try to process it again and try to uh, get the data after checkpoint, it will see a different name here, and lambda durable function basically looks into the database with the step name. So now the step name is different. It will think that, oh, this step was never executed, and then it will try to execute that again. So make sure that whatever step name that you are using, it should be stable or static value. Now here you can see, like for example, we have process item ID, and this will be static throughout the execution, and it will not change. So this is another thing that you need to be careful when you are writing code using durable functions. Number five, and this one, like mentioned in very small prints in AWS documentation, but very important thing to know if you're working on workflows with parallel processing. So AWS stores the results of any child context in the checkpoint database, and this happens with the parallel processing. So if you have like child processes running parallelly, and you have like the size or the return value more than or greater than 256 KB, those will not be saved or those will not be checkpointed in the database. So you have to be careful in uh, checking that. If you feel like your child process might return value which might be greater than 256 kilobyte, then whatever we have learned for all these last four gotchas, you have to make sure that your code is deterministic. Your process or the step name should be static, and all other things what we have learned. So your child process should be idempotent. It should not be having anything uh, outside the step which could cause issues in your workflows, in case if your return value size is greater than 256 kilobyte. So basically, yeah, you have to make sure that the size is less than 256 kilobyte, then it will be checkpointed. Otherwise, those child processes will not be checkpointed by the lambda durable functions. So this is one more important information that you have to be careful about. So let me bring down all the five gotchas that we just learned. First one is the non-deterministic code. So here again, don't use random timestamp values in replays. Always try to capture whatever value you're using in your context step. The side effect outside step. So any step which can change, you have to basically move that inside the step. And then mutating closure variables, anything that you are changing within the step, make sure that you return that value instead of returning something else. And then dynamic step names, make sure that step names are static, stable, predictable names. Otherwise, AWS durable function will try to execute those steps, because it takes the step name and go and check that in the database. If the name doesn't match, it will try to execute it again, and then you will end up processing that step multiple times. And for the child context, again, it should be less than 256 kilobyte to be saved as the checkpoint. If it is greater than 256 kilobyte, make sure that you address all the other issues which could happen in the child process. Now, this is the well-architected lambda durable functions. This is how it basically looks like. So this is an e-commerce order processing workflow. You can see the pattern clearly here. Like every step in the order processing is a part of a context step, and we are basically checkpointing everything running within the order. So this is how it should look like Here, all the names are also stable. There is no code between the steps that could cause any problem. And this is kind of a golden pattern, basically. Like you should follow this structure whenever you are using Lambda durable functions, uh, and should not have any code within the steps. So design your Lambda durable function handler like an orchestrator, where you orchestrate the whole workflow using code and then process those steps and then checkpoint them, so that in case of replace, the value should be same and it should not change. Now, common question I have seen many people ask, like, should I use Lambda durable function or AWS step function? So thing is, like, both solve the similar problem. Uh, Let me break down this very clearly. So step function is a fully managed workflow orchestrator. You define your workflow as a state machine in JSON and YAML file. The workflow logic lives outside your code in this case. In Lambda deliver function, you write your workflow inside the normal code. So you don't have to learn any other language, or you don't have to manage those workflows outside your code. Everything will be inside your code. The second part is like AWS step functions provide you a visual workflow diagram, which sometimes pretty easy for non-technical people to understand. So if you have people who are non-technical and they want to understand the flow, then step function workflow looks pretty good, because then you can explain them with virtual workflows, virtual diagrams, visual diagrams, sorry. Uh, but if you are pretty technical and you feel like you want to have control inside the code, then Lambda durable function provides you that kind of feature. So it all depends on the workflow that you are designing. This is still a very new feature, and I'm not sure how many people like here in the call are they have any experience. Like, do you have if you have any experience with Lambda durable functions, you can write that in comment and let me know what was your experience with that. But yeah, I mean, AWS step function is still the default, go to workflow for the workflow processings, but both has their own, advantages and disadvantages. Now let me leave you with the best practical checklist that you can use for your durable handler. And so before you push any code to production, you can go through this to make sure that everything is as per the best practices. So first one is basically like all side effects inside the step, that you have to make sure that you don't have any side effects. All the step names are static strings or stable identifiers. There should be no closure variables or mutation inside the step. No math.random or date now. They must be captured within the step. And if you're using parallel or map, think about whether the child context result could exceed 256 kilobyte. If so, then you would need to trim that. And test your workflow by simulating a replay. You can interrupt it and see whether the results are coming same for you or not. So what you can do next, you can go to the official AWS documentation, read the durable function execution, and then second, try like building small workflows, maybe a simple 3-step workflow, and then deliberately try to break it with the gotchas that you have learned, and see how you can fix it, and that will give you some good hands-on experience and help you to basically memorize those issues which can happen in the coding when you code with Lambda durable functions, and that way you can get good hands-on experience, and then it will be in your muscle memory, and probably you will understand like, okay, this is not I should do, and this is how I need to design my workflow. So that way you can learn more about it. I think that's it. Thank you so much for your time and attention. We covered Lambda durable functions, the checkpoint and replay model, the 5 gotchas with the real code examples, and I hope this is useful. You can reach out to me on LinkedIn if you have any questions. My QR code is here on the screen. And if you're interested to learn more about AWS or hands-on projects, tutorials, DevOps, and agentic AI, and more, you can subscribe to my YouTube channel. And I just want to encourage you, try building things with Lambda durable functions. It's one of the newest feature, and definitely something to try out in your side projects, or probably in production specific workflows where you can suggest these things if you feel like for this particular workflow this is more ideal compared to other solutions that we have. Thank you so much. Happy coding, everyone. If you have any questions, I can take it now.
You, Hardy. Thank you so much. So I really enjoyed your session, and thank you for sharing with us. So I like the idea of the double lambda function. So code reviews are of course essential. So, but handling the risk of critical bugs even before that is very important. So tips like this are really valuable. And thank you for sharing. Thank you.
No problem.
So
Thank you so much for
thank
having
you.
me. Take care. Bye.
Yeah, good tips. So does anyone have any questions, thoughts, or comments for Harry? Nothing? Okay, all right. And once again, thank you so much. All right, let's move on to final speaker for today. So, Paula, are you ready?
Yeah, I'm here. Can you hear me?
Yes, are you ready?
Okay. Yeah, I am. Let me quickly share my screen.
Okay. Okay. Okay, and if you like to,
Is it?
you can turn on your video.
Okay, all right. Just a second.
Okay, the presentation. Okay.
Right. Can you see me?
Yes. Okay, great. So, change the presentation model.
Yeah, sure.
Thank you. Perfect.
Great.
Great.
Let me just try to minimize this. All right. Good afternoon, everyone. It's afternoon at my end. I think it's about 2:48 here, and happy Eid to every Muslim. So, good day, everyone. Today, in this episode of AWS and Me, I'm just going to share how I see AWS being more just than a cloud. So, my name is Paula Wakabi, and my friends call me Miss Cloud, and I'm a cloud DevOps engineer. I'm the AWS user group leader for Yaoundé, a community builder, and I'm the founder of a community called Women Innovating in Cloud Africa. As I mentioned earlier on, I'm going to tell you a bit about where my journey started. So, it all started with some kind of curiosity. I didn't know what was AWS, what was cloud computing. Yeah, so I just came across some flyers running around about the Restart program, and that's how I got to know about AWS. And I was just like curious about the whole thing, and I was just a fresh graduate, and I wanted to know what cloud computing was. And I was just learning like a bunch of things at that time, trying to have something on my CV that will enable me to like get a job or apply for internship. So that's how I got into the training. And after the training, I got into certifications, and I got two certifications immediately. You know, those kind of situation where you don't even know how you ended up like finding yourself there, and then like you have two certifications. Now you're wondering, what do I do with these two? Can I actually defend those two certifications? And that's the situation where I found myself at that point, and I didn't know where to go next. So the reality started hitting me. I applied for many jobs. I got rejected every time. And because I had the solutions architect certifications, I thought that it made me a solutions architect. So I was very, very confident. Anytime I see any job offer saying this is for solutions architect, I'm just going into it. Like I'll just apply without thinking. But for most of the jobs, I noticed that they kept asking for 2 to 3 years of experience. And I'm like, where am I expected to get those years of experience? Like, in fact, I want this job in order for me to like get those first years of experience. So how are you expecting me to get that? So I was somehow lost. I had like a lot of questions going through my mind. What should I do next? And then that's when I discovered uh the different type of cloud roles through AWS communities, and I got to know what cloud engineering was. So that moment felt actually like I don't know if some of you heard the story of Punch. So I was like Punch at that time, and uh, the rejections coming left and right. I was just lost, finding myself in the midst of people that didn't even know what I was going through, people that could not even relate to the cloud stuff I'm even talking about, because most of the people around me were not even doing cloud computing. So I was just there trying to connect with one another, but there was no sense of connection. They didn't really know the kind of support I needed and all that. And yeah, that's how I just came across the AWS community. I met with Veliswa, and she introduced me into the communities that were uh, in the AWS user group in Douala. Because at that time, I only knew of the AWS user group in Kenya. And after getting introduced to the one in Douala, that's in Cameroon, I was like, okay, well, I guess I'm going to learn from these people as well. And from there, like I got to also start my own AWS user group in Yaoundé. But before we get there, let me tell you so how those communities actually changed everything. After I discovered the AWS user group, I got to learn a lot through the people. I connected with people that could actually like relate to whatever I was going through, people that could tell me that whatever I was actually going through is something that they've already experienced. And they were kind of guiding me towards like uh, uh, finding the exact career path and also realizing exactly what I like doing. And that's how the AWS user group in Yaoundé was actually born. So from there, initially I used to be the kind of person that is scared of the crowd. I used to be a very shy person. Yeah, a lot of my friends don't actually believe that, but I used to be very, very shy. And coming from a French background, it wasn't very, very easy because most of the AWS services and the resources available online were at that time uh, in English. So I had to like find a way to understand everything in English. Even if I wanted to go into like public speaking, most of the people I surrounded myself with only speak English because I'm no more based in Cameroon. I'm in Ghana currently, so it was somehow difficult. But I just decided that I needed to come out of my comfort zone, looking at the fact that like now I have like a number of people around me that were doing some of the things like that have been inspiring me. So I was like, I don't need to dwell in this kind of fear. I need to like take initiatives. And that's how I joined AWS New Voices, where we were taught a little bit about public speaking. And that's how my journey into like sharing knowledge and experience started. So after the program, I tried to like speak in many events, even though I was already the AWS user group lead. I wasn't really like speaking in sessions, like technical sessions and all that. I was just organizing events, and I was learning how to like interact with the different speakers and all that. And that helped me a lot with gaining self-confidence and growing also like in my career. Then came the moment when they started calling me Miss Cloud. So a bunch of my friends call me Miss Cloud, and uh, it got to a point I was just like, well, if they are calling me Miss Cloud, and then I cannot even defend that title. When I attend events or when I'm on campus, I think like when started I was doing my master's, they would just be like, "Hey, Miss Cloud," because they've been seeing me like posting resources about um how is it called, AWS. And like I just feel like, what if one day they actually introduce me to my potential employer, and then they're like, yeah, she's very good in AWS. Like she's the AWS user group lead for this community, this and that. But then when I'm given a real task, I won't be able to like to complete it. So the question started dancing in my head. It felt like a pressure at some point, because now I needed to really like smile anytime I hear like, hey, Miss Cloud, instead of me being scared of defending that title. That's when I started learning. My journey of growth started, because now I knew that if I want this, I needed to like work for it. I needed to defend the certifications I had. I needed to defend the title of being like an AWS um, user group lead. So I started joining boot camps, watching YouTube videos, writing blog posts, and even like getting projects online. And that consistency with learning actually helped me even land my first um, cloud role. And from there, I got like different offers from different companies. After like kind of updating all those things like on my LinkedIn and all that, so they've been a couple of companies reaching out to me, and they are like, okay, we have these openings in this our company. Would you like to explore what we are giving and all that? And I was like, so this is what I should have done like from the start, you know. And there are times I'm like, I wish I had people like that in my life from the start, that would be guiding me through all these things, so that like probably I would have been very, very far, or maybe much more better than this. And this made me think about other things. Why don't I be that person? Since like during my time, I didn't really get those people at the initial stage. Why don't I actually like start something that would make young women uh, learn about these things quickly, early in their early career. And probably this is going to make them like save a lot of years in their career, and then like grow quickly, instead of uh, waiting until like they've wasted 2 or 3 years after graduating from university, and then like meeting mentors, and then like getting introduced to communities and that and all that. So I started a community called Women Innovating in Cloud Africa, where we usually just train people into different aspect of cloud computing, and we have like partnership with other communities that offer scholarship to those young women to learn about this. And we kind of also spotlight women that are in this field of cloud computing. Anytime we organize like workshops, boot camps, we make sure that most of the women in our circles that are good with cloud computing come there to share their knowledge and their experience, so that the younger ones could also get to learn more about these things in their early career, and then like possibly grow quickly than us. And as time went on, I realized that I already have like a full circle of people that inspire me and people that also inspire. And this is how I realized that, like joke, I started making some impact around me. And uh for some months I've decided to just like um share about my experience, especially like this month since it's for women. I decided to share what I have learned with how I decided to share my journey, sorry, how I got where I am right now with many people around me, so that they get also like inspired, and then like build the self-confidence in whatever they are doing. So this is the reason why I titled this session. AWS wasn't just a cloud for me. So to me, it was a circle where I found inspiration, a circle where um, my growth started, a community where I was able to fight my should I call them insecurities, where I was able to come out of my comfort zone and become someone better today. Yeah, I guess I've already covered this part. Yeah. So AWS is just more than a cloud for me. It's also a voice where you know you hear things that are coming from other people, and where your voice also goes um everywhere in the cloud. So basically, yeah, AWS helped me build my confidence and build also a community around me. So it's not just like a technical platform where you go there to build technical stuff, but it's also a community where you can build relationship with the people in your environment. So if you find yourself in a community or in any form of circle of people that are into cloud computing, don't just join for the technical aspect. Try as well as you can to also connect with a lot of people. When you join meetings and all, try at least to like reach out to those people at the end of the session. Hey, I saw you at this particular event. It doesn't have to be in person, it can be online. Just reach out, interact with them, let them know where you actually maybe saw them for the first time or heard their story, and connect with them. You don't know where it's going to lead. Enlarging your circle can take you to places where sometimes even your skills cannot take you to. It can open doors that sometimes even your technical skills cannot take you to. So sometimes technical skills without the essential network or the community will not really take you that far. So with the technical knowledge you are learning, try to also surround yourself with people, network, be part of many communities as you can, and try to be active there, connect with a lot of people, share your experience, because it's through the sharing of your experience and um the feedbacks you'll be getting from those people that you keep growing daily. So just don't think that maybe as you have already learned a little now, it's okay. You don't need to learn again anything. We keep learning every single day. Yeah, so as a closing remark, yeah, I would just say keep learning, keep doing what you're already doing. If you are a builder, keep building, share your knowledge online. Let people give you feedback on what you're doing. That will push you to a higher level. Keep connecting with people around you, and don't treat your field or AWS or the cloud as just a technical tool. Just see it also as a tool that can help you build relationship around you. So this brings me to the end of my session today. Thank you guys for your attention.
Thank you for thank you, great story. Thank you so much. And greeting to you in Ghana. So right? So, and I'm really happy to see many AWS friends from Africa joining this meetup, right? So that means a lot to me. So it's wonderful to hear how AWS certifications and the community are supporting your career. So I totally believe this kind of experience can make a real difference. So for me as well, this community has made my life richer, and it's all thanks to everyone here. So I have one question for you. So, in your country, is being a cloud engineer something common, or is it still something rare and valuable?
Okay, so um, in my country of origin, I think it's somehow different from where I'm based. In Cameroon, for instance, there's definitely a rising number of cloud engineers,
Mhm,
but it is not as much as it is in English-speaking countries. Because
mhm,
Cameroon, it's true that we speak like both French and English, but it's dominant. French is more dominant over there, and uh, most people are now getting to know what exactly cloud computing is.
mhm.
So especially AWS, you would definitely find people that are into like all those Google kind of communities, but for AWS, it's very, very new. And I
Mhm.
think we just even recently like started having a rising number of cloud club captains in
Uh-huh.
Cameroon. So
Oh,
the number of cloud engineers is increasing, but it is still growing. But in Ghana, we already have like a lot of companies that use AWS. We have a lot of organizations and community that train people in AWS, just like the Restart program. And also we have like a lot of cloud engineers
yeah,
already growing around, but we still have like just our first two cloud club captains this year.
yeah, too.
And yeah, so that side's also growing. Yeah.
Thank you. Thank you for sharing. So, does anyone have any question or comments or thoughts?
I've also shared my LinkedIn link in the
Oh,
chat.
great.
So if you'd like to connect with me, if you are from Africa, or if you would like to join the Women Innovating in Cloud community, you can connect with me on LinkedIn. And yeah,
Okay, thank you. Once again, thank you. So personally, I'd love to visit your country someday. So because
right, you're welcome.
yeah, because as the origin of humankind, right? So I'm a traveler after all. Thank you.
That would be great.
Yeah, I hope. Thank you. And now let's move on to our closing talk. So yes. So before we wrap up, right? So let's give a big thank you to all of speakers. So and now we are coming to the uh, end of today's session. So I'm really grateful that we could spend this time together. So and to everyone who stayed until the end, thank you so much for being here. To our speakers, thank you for sharing your experiences and perspectives with us. So your talks made today to really meaningful. So we had so many different stories and ideas from different backgrounds and viewpoints, and that diversity is what makes this community so special. So this kind of moment remind me why we started this community in the first place. So before we close, please feel free to share your social links in the chat so we can stay connected beyond today. So if you enjoyed this meetup, I'd be really happy if you shared it with your AWS friends as well. Every new connection makes this community stronger. So, and if you are interested in speaking, please free to reach out anytime, right? So we'd love to hear your story. So let's keep learning, sharing, and growing together. So I'm really looking forward to seeing you again next time. Have a wonderful rest of your day or evening, wherever you are. So see you next. Bye for now.